Let's come to the very important chapter, that is occupancy over here. We'll be talking about the occupancy. Section 4.5 clearly defines what the occupancy we should take per room or per area. Uh, in most of the majority of the drawings, you may not find this occupancy, so you need to assume some kind of an occupancy for these areas. So when the drawing comes to you, of course, these thumb rules you can use, which is clearly stated in section 4.5 for the occupancy. For cabins, maximum number of persons for which the cabin is designed, that you can find from the number of beds which is kept on the or shown in the cabin. So you can easily find out the number of people. So suppose there's a bunk bed is there, of course you can say two people are for the cabin. For saloons, one person per 2 square meter of floor area. For mess or dining room, one person for 1.5 square meter of area. Then for recreation room, one person for 5 square meter of area. For captain or chief or engineer's day room, it's 4%. And other private day rooms, it's considered 3%. For hospital, medic room, it is number of person plus two, number of beds plus two people. For gymnasium or the games room, 4%. And for first aid room, two people. For offices, two people. For machinery control room, three people. So this is what you can use for this section 4.5 for the occupancy of the areas. So let's go. Hope the topic is clear, because air conditioning, when you design, you need to decide the occupancy. So these are the areas, these are the rules. Section 4.5 you can use, and you can apply that to the system. Now let's go to the next one. Here section 4.2, if you see, it talks about heat transmission and gain loss, and this is the formula which has been given over here, and this is what each one means. So let's see what it means over here. And when we talk about this section is 4.5, and obviously this formula talks over here about the heat transmission or heat gain or heat loss. So what is that? Let's go one by one. Is delta T is nothing but the difference in temperature in degree Kelvin, that is difference of air temperature between the air conditioned and non-air conditioned internal spaces. The kV here stands for the total heat transfer coefficient in watts per square meter per Kelvin for the surface area. And let's go to AV. What is AV? AV is surface area in square meter, excluding the side scuttle and rectangular windows, and glazing plus 200 mm is what the section 5.2 talks about it. Then let's talk about the kg. It is not a kilogram, but it's a total heat transfer coefficient in watts per square meter per Kelvin for the surface area Ag. And what is Ag again here? The surface area in square meter of side of the scuttle rectangular window, that is glazing by 200, is what is Ag. So if you put all these values over here, you will get the heat transmission or heat gain loss for the windows. So anyway, let's go to the next one, so you'll understand in better way the other factors also. Now here we are going to look at the temperature difference between the adjoining surface. Section 5.2.2, temperature difference between the adjoining thermal spaces for the difference of the temperature degree Kelvin between the air conditioned and non-air conditioned internal spaces. It's mentioned in table 1 of section 5.2.2. What does it mean? Suppose you have one room air conditioned and other room non-air conditioned. There's a partition between. So these are the guideline temperatures difference delta T, which is given and which we have to use it while calculating the heat load calculation. So wherever the partition section or partition portion of the calculation is coming, you need to use these values. So let's go one by one these values. What are these values? One is the type of bulkhead. Bulkhead, as I explained earlier, bulkhead is nothing but a wall. It's a deck against tank provided with heating. Suppose your wall or bulkhead is against the tank with a heating, then for the summer you need to consider delta T of 43, and winter you need to consider 17. Similarly, for deck and bulkhead against the boiler room, is mentioned over here. Then deck and bulkhead against the engine room and against the non-air conditioned gallery, you need to consider 18 degrees Celsius. Then again the bulkhead against the non-heated tank, cargo spaces and equivalent, 13 degrees Celsius. Then deck and bulkhead against the laundry is 11. Deck and bulkhead against the various sanitary spaces is 6 degrees Celsius. And deck bulkhead against the sanitary spaces of exposed, non-exposed and other areas, you need to consider respectively 2, 1, 6. And bulkhead against the galleyways, storeroom, equivalent spaces and equivalent trunks are considered 2 degrees Celsius. So this is what are the guidelines given. So just you need to mark it up properly before going to interview, and the temperature difference between the adjoining spaces is explained in this particular section 5.2.2. So these values are also being commonly asked in the interview. So you need to take a note of it. And always remember that these are the provisions for ISO 7547. So you need to understand the standard very well for going to interview, and you can tell to the interviewer that this is what the standard we have used. Let's go to the next slide.